The Kokoraz Educational Series is proud to present Watersheds. Do you live on land?
No.
No. Well, if you're not like these guys and you live on land, guess what? You are living in a watershed. Now, a watershed isn't this, or this, or this. And it's definitely not to be confused with a water closet, which is an old-timey term for a bathroom. No. A watershed is an area of land where surface water drains down to a single point, be it a stream, lake, or ocean. A watershed, also called a drainage basin, collects all of the water that doesn't first get evaporated or transpired, whether it's from rain, snow and ice melt, sprinklers, spilt slushies, or even... Oh, yes, my old nemesis, water balloons. It's like a big funnel that drains down to one spot. The area of a watershed is defined by topography, the shape of the land. Its borders are marked by the drainage divide, the highest ridge that divides the water from falling into its own basin rather than that of another. To visualize it better, let's take a look at this roof and its gutters. The rain that falls on each side ends up draining into its own gutter. The drainage divide is marked by the peaks of the roof, and each section could be considered a watershed. The area of a watershed is also defined by what common source of water it flows into. Jennifer lives in a watershed that flows into a nearby stream. That watershed, along with neighboring watersheds, make up an even bigger watershed, made up of other neighboring watersheds that make up an even bigger watershed. You see how this could be pretty confusing, but luckily we have an easy way to classify watersheds. We use HUCs, or Hydrological Unit Codes, which is just the fancy name we use for a watershed address. Think of it like a jigsaw puzzle. The first number represents one piece of a puzzle made up with relatively few pieces. The second number represents a more complex puzzle with even more pieces. You can keep breaking up the puzzle into more and more pieces until you get your full address. This is Jennifer's address. But no matter where you live, it's in a watershed.
Arr!
Right. I'm not talking about you guys. Looking at these maps, you can really start to understand why it is so important to know exactly how much precipitation falls in what specific areas. Take McNamee Peak in Colorado, for example. You could have 3 raindrops fall within just a few feet of each other, but end up in completely separate watersheds. Those few feet could end up in differences of hundreds and hundreds of miles. This is why having lots of precipitation measurements over a wide area is so important. At Kokoraz, volunteers just like you contribute precipitation data that allows water managers to better calculate how much water they can expect in their basin. While a single measurement of 0.3 inches doesn't seem like much, when it's averaged and multiplied over a large area with all the other data, it can start to add up quickly. Let's go back to our roof example to see how much water could be collected from a small rain shower. As explained earlier, there are 3 different watersheds, meaning 3 different places where the water runs off the roof. Let's look at the front watershed. 30 feet by 10 feet equals 300 square feet of roof. Let's say that it rains a half an inch over this house. On this watershed, that ends up being over 93 gallons of water. Now think about the same thing on a larger scale. Even over a small watershed, if the entire amount of rainfall washed downstream, it might be enough water to fill up a stadium. There are a lot of other factors that go into estimating how much water fell within a watershed, and how much is going to be running off and moving downstream. Scientists use many sources of data to predict runoff. How much water seeps into the ground depends on the type of soil, how absorbent it is, and how much water is already in the soil. It depends on how much plant life is around and the rate at which the plants use water. It depends on how warm or dry the atmosphere is, which determines the rate of evaporation. It depends on how much water is stored or used by people for cities and agriculture. Knowing these factors, scientists, specifically hydrologists at the National Weather Service, produce what are called hydrographs, which are basically graphs showing the past, current, and predicted levels of streams and rivers across the United States. Thinking about all of the factors that go into a hydrograph, you can see how complex it is to determine the amount of water that will flow downstream after a rainstorm. But it all starts with one crucial measurement: precipitation. And that's the one you take and report with your gauge. So get out there, grab a friend even, and make a difference in determining the health of your watershed.